Right, I'm recording this unpacking, not because anyone would want to see me unpacking anything, but because I'm not 100% sure what it is, but I think I know what it is. And great, look, I'll get a knife that's so blooming blunt it can't cut through a piece of plastic. Well, it's well packed. Because I recently had an order from China of a motor, and when it arrived all I had was an empty bag. There was no motor in it. The motor had ripped its way through the bottom of the bag and gone AWOL. This, I'm hoping, is also electric motors, but of a different type, and they feel quite sturdy. Now I'm told, although it doesn't seem to actually say, but I'm told from the advert, oh yeah, there it is, Johnson. So this is a genuine Johnson motor, and it says 18V there. I'm not 100% sure if that's supposed to mean that it goes in an 18 volt tool, and that's what it would have been originally, but the seller said that these operate from 12 volts to 24 volts, so I guess 18 volts would be a happy medium, wouldn't it? But the reason I want one of these, and of course now I've got two, but the reason I want one of these is I'm wondering if I can use it to convert the Dremel sander to a low voltage, because I've had no luck at all trying to get 240 volts to work with that sander. Right, that's a Makita 12 volt battery, well 10.8 volts, but obviously it's actually 12 volts. And of course a bit of wire keeps trying to pop out the end of it, what a surprise. But let's see if that'll give us an idea of how much oomph we've got. That's a fair bit of oomph at 12 volts. Wow, you can feel this give a really good kick. Look, I'll try and hold it gently. See? That is quite a kick. Yeah, I would say that motor is going to work quite well at 12 volts. Maybe not spinning fast enough, but it's certainly got plenty of power. Now the seller did warn on the advert that these are reasonably high current, so you can't run them off of just any old cheap power supply. It's going to need something that can put out perhaps say 10 amps or more, just to ensure that the motor is happy and you don't damage the power supply. Right, that's the Proxxon sander. That's the motor that I'm hoping will fit. This is the cog that came off of the original motor. As you can see, it don't fit. Now I have made a tiny little reducing bush that will go in there. It doesn't want to go in at the moment because it's a tight fit, and that might go onto there with a bit of luck. But also I purchased this for eBay, which I believe is the same size, give or take, but the middle is smaller. But somebody has got different versions of measurements here, because this is supposedly I think 3.17 and this is 3, and you'd think that 0.17 would be, you know, close to fitting, but it doesn't look as if it's anywhere near close to fitting. But we'll worry about that later. What I need to find out is what size are these, and that's the original screw from the original motor. So does that thread fit this motor? I think there's a very good chance it will, and it does, so that's good. But of course, how does that gap compare to the original motor? And the only way to find that out is to open this up and have a look. Right, so we don't need that bit. That's where the variable speed, on-off switch, variable speed, they were all built into there. Motor housing. It's got two size connections, so it looks like it could take two different size motors, so fingers crossed this will fit. I've got this, I don't know if that's going to be of any use now, but the biggest problem is, does this, oh yes, the measurement said it would fit, and it does. Look at that, perfect, and perfect fit in the middle. Now you can see from there to there holes don't line up, so it doesn't fit that way. But if we go this way, oh, it's a perfect fit. So we just need that to fit on there. Right, it's only soft metal and it was very close to being the size it needs to be, so I'm going to try and just run it out slightly larger by holding it like that and hand turning this. Obviously once it starts to bite, not quite so easy, but it's going. It's getting more and more difficult to hold, that's the only problem. That's I daren't let it get damaged, because obviously the teeth are an important part of this. But when we're only taking out, what was it, about 5/100ths of a millimetre, we've still got a way to go. And we're through. Right, now, so that was sold as 3, but obviously it wasn't quite 3. Let's see how tight that's going to... now I think that might... Yeah, I think that might press on. It's very difficult to know, and obviously I don't want it to be a loose fit. That is the biggest problem, because I want it to power that head. I'll try gently pressing that on, but of course you see if it's not, you know, if it's too tight, this will split. Especially as a lot of this Chinese metal is not the sort of quality that you get from other suppliers. But funnily enough, I could not find this size anywhere but China. Right, I've changed my mind slightly. That's a 3.1mm drill, so I've just taken it out to 3.1 because I'm really worried that if I use 3, it could split this. This could end up too loose, but I'll take that risk. And I measured this with my micrometer. The micrometer says it's 3.17, which is what the seller says it is. I have got a press, but I don't really think I'm going to need a press for such a small thing, so I'm going to try and push this on with this little vise. Obviously the back of the spindle is at the back here, so the motor is not under any strain. Is that... Yep, that's pretty much all the way through. I think on the original setup that gap was a little bit, well, I know it was a little bit smaller, so because I couldn't get a puller behind it. So what I'll do is I'll put a couple of washers on here and press it one more time just to lower that down a fraction more. It probably doesn't matter, but I will do it anyway. Right, you might just be able to see it's pressed on just a tiny little bit further there. I just put a washer on the end and pressed it a fraction more. This was designed with a hole in the middle, so it allows for that. Hopefully that fits, which it does. So there we are. Now of course, will it all turn in the right direction? Well, it doesn't really matter because I guess we can just run the motor backwards, so I won't test it. Right, let's have a look at what we've got here then. So we know that that can go in there. We know that's got a choice. That can go there. Where does that put my connections? That puts that one down there. It doesn't really matter, I don't think, does it? Because if I turn it round, that's just going to put the red one up there. It's not really going to make any difference to anything, I don't think. And presumably that is going to be the right depth. Certainly looks very similar to the original. Not sure if we need that or not, we'll see. Right, so let's have a look. So that is going to be difficult to get into there, so let's find a small screwdriver. Is that going to go in there? Yeah, that's not too bad. Let's see if we can get this in here without dropping it. Yep, that's one. It's almost like it's got some thread locking compound on it, but it's weird because it's right up at the wrong end. It's up where the screw would rest against the plastic, so I'm not quite sure what the point of that would have been. I'm not sure. I've cleaned this so well now you can't see if that would have been a case there. But let's see, that goes into there with no trouble. That's going in. I don't think these must need to be fantastically tight. Right, let's just check we're not hitting anything. No, you can feel this has got very strong magnets in it, this motor. You really feel it. Right, so what was that for then, that bit, do you think? Just a spacer? I could look back at the old, when I took it apart, see if I can work out where it sat. That's, so it would really have to go that way, wouldn't it? Short leg there, long leg there, long leg there. Yeah, so it looks like it goes that... Oh! Unbelievable! It's a perfect fit! Absolutely perfect, as if it was made for it. So does this now... I can't believe it! Look at that! Well, I'm just too amazed for words. So, if I get a red pen, I'll make a note. I mean, at the moment, that is opposite that red mark, but of course that could move in the future if I was to take it out and put it back in a different orientation. But if I mark that and that like that, and then if I do this one with two marks, I pretty much can't get it wrong. Well, I'm gobsmacked. I wasn't expecting that. So that will go in there. They're going to go through there. That's going to connect onto there. Right. So the problem I've got now is how do I hold all this together while I practice building the rest of it? So it's either that facing up that way or that facing up that way. Anything on this side to give us a clue? Possibly, I suppose. I mean, we've got that there, I don't know what that is. What would that have been opposite there? I mean, the reason I need a rough idea is because I'm going to need to hold these in place, aren't I? But I won't be able to hold them in place because that's not going to screw all the way in. Because it used to have this cap on the end. Yeah, see, that's going to stop there. So we'll need some sort of spacer there. Because I need to assemble this without that piece, because that's the only way I can get to the wiring. Because obviously I need to get to the motor to decide what to do with the wiring to the motor. Because one of the things that I'm quite interested in is, can we put the battery back here? And if we can't, well, we can just put this back but connect it to a nice powerful 12 volt supply. So it's possible. In fact, I might do the 12 volt supply because I can't see any reason why I'd ever want this as a battery powered tool. Found some washers to act as spacers, so that's all held on there now. So there we go. Right, crocodile clips, plus and minus, onto the motor. Two little bits of metal poked in the top of the battery. Minus is connected. Plus right, there's a bit of metal with a cut end. I'm not going to do any real serious work with it, but we'll pick that up. Let's see what happens. Oh, it's not slowing it down, is it? Maybe a bit. Oh. So you can see from the sparks earlier that it's taken a fair bit of current. But look, it's put a bevel on there in next to no time. So clearly it's working. Belt didn't fly off and take my eye out, so we just need to improve. We've got this going, we just need an improvement on this. Right, I've just bought this. It's a Meanwell power supply, and it's 240 volts, or you can run it on 100, 110, but obviously I want it on 240 volts because I'm in the UK. And the output is 12 volts DC, 12.5 amps. So I'm hoping I can use this to power that motor. Small power supply, hopeless, won't start it, won't do anything, it won't turn it. 12 volt battery, absolutely fine. Will 12.5 amps from this be enough to power that motor? Don't know. So that's what we need to find out. Alright, so we've got live, if I can get that to tuck under there. Live, neutral, and then earth is playing hard to get. Come on, go the same side, those have all gone. Oh, there we go. Right. So live, neutral and earth, which in Europe is brown, blue, and then green and yellow. Considering how much metal is on the case of this, I'm not surprised it needs to be earthed. It will need to go into some other kind of case to shield it, because obviously all this is exposed. Right, I just found these wires with connectors on in my scrap wire bin, so we'll use those for now. That one's going to need squashing down because it's way too loose. That one's going to go on. Let's give these a bit of encouragement. Usually I find I've squeezed them too tight and then I can't get them on. Oh no, that's still loose there. Oh no, that side's gone tighter. I don't know what size spade terminals are on here because they seem too wide. But we don't need anything wonderful at the moment because this is just a test. So we'll just poke the wires in for now. I'll put the proper connection on it later. But obviously it won't be with these wires. So that's V plus, and then we want, and it looks like we've got a possibility of 2 outlets. I don't know if that means we could use 2 at once, because we've got 2 V minus and 2 V plus. But I can't see me wanting to use 2 things connected at once, so it doesn't really matter. Right, found the extension, so we've got something we can plug into. That's our motor. I'm assuming that we'll hear that start. I don't think 240 volts is going to jump straight from there to there and across to there, but well, I mean, you never know in life, do you? Right, I'm going to switch this on and let's see what happens. Let's hope it doesn't just go bang. That sounds like it's running okay. Oh! And it's just ripped my glove to bits. Yeah, I think that might work. So, don't put gloved hand near spinny thing. Not a good idea. Right, the reason that I want this is because I want to power this and run this on 12 volts. We've got the old original 240 volt lead, so that can become my 12 volt lead, so that could still go into here. The on and off switch will still work, but this, the variable speed, will not work unless I can find a way of attaching a variable speed board in here. Right, I've made up these 2 smallest size crimp leads and I'm going to use these on the motor. These have got like a little pep on them that helps lock them on, so they should be reasonably good at withstanding vibration. You can see they are really tight. So I've got a feeling that that might be okay. If it's not, obviously I'll end up soldering the connections, but I'm going to give it a try like this to start with. Because once that's on, that is pretty solidly on. Now, I think I'll switch the positive side. It doesn't really matter which side you switch because we're talking about low voltage anyway. But if I'm going to switch this side, then this needs to come through the back here because that's where the switch is going to be. And then this is going to become the other side of the switch. So we'll have power in through the switch, power out to the motor. I've just added a bit of heat shrink to these wires. I'm not even going to bother to heat shrink it down. It will just make this look less like a live cable, because obviously this now will be black for our negative wire and red for our positive wire. Right, there's the wires all coming through here. The lead goes in the bottom, wires come back up here. One red wire on one side of the switch, so if we solder that on. Right, this is the other side of the switch. So that's the switch done. So we can, in a minute, we can push the switch in and in its place. And next I need to just join these two together because obviously they're just going straight through to the motor. So I don't think it's going to make any difference whether it's a lovely inline joint or anything. Right, hopefully that's plenty in there. Right, I think this heat shrink's got glue on it, so once that's on there, I can get that over there. Leave the end inside a little bit where it won't be exposed. That should shrink down nice, then we should be able to just pinch that end shut, and that should be it. So now we've got our negative wire coming all the way in, straight to here, straight across to the motor, positive wire coming all the way in, going to the switch, from the switch to the motor. So we just need to get all of this tidied back into there. Right, that's all pushed back in. There's our switch. Obviously at the moment we're not using that, so it doesn't matter whether it's there or not because it's not doing anything. That needs to turn over slightly to go on to there, so that, when we can get it to find the right spot, oh there we go, that is going to go there. I think that's the right spot. So now it's just a case of getting these into the right place. Now I don't want to start off power screwing that in, so let's see if we can, no, so that's not in the right spot. Now that's starting to go. I just want one of these to hold everything together. Right, so with a bit of luck we can put the others in okay now, so that's one in there. Yeah, that's going in. I just want to make sure nothing's cross-threaded because you can bet that if you cross-thread aluminium it will not be fun. And I think that that one is a little bit dodgy anyway because every time I put that one in it doesn't feel comfortable, whereas the others all feel absolutely fine. Well, you can see how easy they're going in. Right. That on there, let's put that on a fairly low setting, we don't need it too heave-ho. Right, here we are. So there we are, that's on. There's our switch. If we press this in like that we can move this out to the front, that's a bit easier to deal with. Right, here we go then. I've put some heat shrink on here, so we've got red for positive, black for negative, so we now know that this is all 12 volts connected to here, which is our power supply. Like I said, this won't reach to my sockets, but of course it will now if I move it over where you can't see it, but now it will reach the socket, so I can, whoa, and we're in business already because I've left it turned on. So let's turn that off, push that back over there. Right. Right, this is a bit of old rusty metal. You can see it's quite pitted in places, and obviously this isn't intended for anything like that, but at least it will give us a guide as to what it's doing. there's almost splines there. Ooh! Oh, is that just that? Not the motor smoking. Well, I think if it does that, a solid piece of steel, fairly easily, then obviously it's going to work quite well. It gets a bit warm. Obviously you can't see it, but this is getting a little bit warm, so I'm not sure how happy the motor is. We'll just have to use it over a period of time and see how it goes. So there you have it. One Proxxon sander, now converted to 12 volts, running from 12 volt power supply, and it seems to be running okay. Job's a good one.